This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data with Gen AI. Friends, in previous session we were discussing about the different tasks that we can perform with the help of Gen AI, and we try to utilize different models. And Probably you have gone through with the Google Colab, and I have shared the notebook as well. And probably what I'm expecting at this moment, you have gone through with the practical, and you are having the enough understanding, like the pipeline is there inside the transformer library, and with the help of that we will be able to import a particular model, and with respect to the specific task that a model can perform, we will be able to do the task. It might be the sentiment analysis, or it might be generation of new, you can say, content or text. So there are different things. There are certain more examples we will cover on in the upcoming sessions, but in today's sessions it will be the short session, and it will uh, be the theoretical one. I will guide you. I will show you certain threads where you will be able to visualize the things. And this particular session is to set up a base that how the transformer architecture is working internally. I will try to visualize certain threads, and you will be able to get the understanding, and then we will drill it further to have the deep understanding. So so with respect to the thing, say if we are willing to perform thousands or millions of calculation, say if I want to perform millions of calculations in a second, then how much time it will take? It will take to pre-train the model based upon these operations. Okay, you can think in this particular way, like we are having lots of applications, and those applications are running, and what we need to do, we need to pre-train our model based upon that those particular transactions or operations which are being happening. Okay, you can think like certain stock market uh, operations are keep on going, and the stock prices keep on increasing or decreasing, and based upon that particular data, like if you have pre-trained the model, and the model will be having the information, say if one stock price is increasing, what is the impact of the onto the another stock price if this one is increasing, or what is the impact onto the entire sector, say healthcare is a sector. Okay, uh, uh, government, or you can say oil and gas is a sector. So there are different sectors. What is the impact of one stock onto the different sector? So say you have pre-trained the model, but how this particular pre-training is possible? Why it is possible? This is possible because of the GPU architecture. GPU, that is graphic processing unit. So previously we were having the CPUs. Okay, and CPUs are limited with respect to the processing capabilities. They are not capable to handle the data, huge amount of data. I'm talking about, say, millions of transactions, millions of, say, calculations or operations. You can think in this particular way. If I'm having this much of calculations and I'm willing to perform in 1 second, then it will take hundreds of years in order to calculate if I will proceed with the CPUs. So the GPUs are the one thing. Because of that, this pre-training is possible. And second one is the transformer architecture. Transformer architecture. So if I'm saying that I or say kids want to, and the blank space is there, and over here it is saying say play. Okay, so GPUs we are able to know, like this is graphic processing unit, and at this moment we are having NVIDIA A100 or H100. That is the gold standard for the training LLM. Okay, this is the most, you can say, powerful GPUs infra or hardware available at this moment. There are certain hardwares like TPUs which are used for the GenAI model training. This is limited to Google only. And there are NVIDIA 4090, 3090. These are the, I'm talking about the infra or hardware which are utilized in order to train the GenAI models. Okay, so because of this advancement, or because of this particular infra, we are able to have the pre-training. If the millions of operations or billions of operation, I can say, if billions of operations are happening, then I will be able to process in 1 second, and that is possible because of the GPU architecture or GPU infra what we are having. Second one, the pre-training and all. Okay, this is not possible because of, if we are having the GPUs and if we are not having the transformer architecture, definitely we will not be having the Gen AI. So transformer architecture is also a building block, and it is, you can say, the fundamental stuff if we are talking about the Gen AI. Yeah. So Gen AI is possible because of these two. These two are having the major role in order to have the Gen AI. Okay. So what exactly is being happening inside the transformer architecture? If we are providing certain sequence of, you can say, tokens, this is nothing but sequence of tokens. And how we are able to predict the next token. Okay, kids want to, and space, this is the predicted one. It might be possible like kids want to prank, kids want to uh, uh, go out. Okay, kids want to study. Okay, so there might be a number of variations, but how the transformer architecture is able to predict uh, nearest to the correct one, nearest to the real answer. How this is possible, that we will be going to understand what exactly is being happening inside the transformer architecture. So let me show you one thread what I'm having. So this is Polo Club dot github.io, and over here we will be able to understand the transformer architecture. There are certain things which you are able to see, like embedding, then multi-head self attention, MLP, a transformer block probabilities, and all. No need to worry about this. Just try to understand the things at this moment. Just try to visualize these particular things. Okay, so if I'm giving, like kids like to, and say I'm going to generate it, and it has predicted, say, play. Okay, kids like to play. So play is the predicted word. Let me refresh it, so it will provide. It is the page is not responding. It might be because of the heavy website, heavy content is there onto this thread. Okay. And over here, data visualization empower users and to visualize is the predicted word, and over here if you are able to see the probabilities, and guys, if you are able to see empowered to create, empowered to see, empowered to make easily, quickly, okay, explore, find, understand. These are the other predictions as well, but the probability is less over here, and whatever is having the higher probability, that is picked as an answer. Yesterday I was talking about the temperature. Okay, temperature is used to restrict these particular output. So if I'm decreasing the temperature near to zero, if then it will provide the single answer. Okay, it will restrict my output to the single one, and it will be uh, it will not a generalized outcome. Okay, it will be, you can say, this particular answer is not natural at this moment. Okay, so over here you will not be getting the multiple variations of the outcome, but if we are increasing this temperature, then you will be getting more and more answers. Okay, and the answers will be more generalized if we are able to see, create, see, make. Okay, and how these particular things are happening, just have a look. If I'm passing certain sequence of tokens, these are nothing but tokens. Okay, and just have a look over here what is being happening. So these are nothing but data visualization, empower, and over here which type of tokenization mechanism is used, which type of tokenization mechanism is used over here?
Subword.
Sub-word level tokenization. Data visualization empower was the single word, but it has, you can say, divided it into two, m and powers, users too. Now the tokens are there. I'm having the sequence of tokens, and these sequence of tokens are, you can say, given for the token embedding. Like tokenization is being happening over here, like data is having 6601, visualization is 32 uh 704. These are the nothing but the tokens, over here. And with respect to the tokens, we will be having the positional embedding encoding. So over here, with respect to the given sequence of tokens, it is going to calculate the positions of those particular tokens. And with respect to the positions, like once we club these particular two, we will be having the final, you can say, final output. So once like the position is used in order to check the priority, and all those particular things will come into the I will explain it in detail. Okay, so what is being happening, the data what we are giving, that is converted into tokens, or the sequence of tokens what we are giving, that is tokenized, and uh, it will be clubbed with the positions, and then we will proceed with the attention mechanism. Okay, so friends, inside the transformer architecture there are two main things, attention and MLP. Okay, multi-layer perceptron. Multi-layer perceptron, or what we can say, we used to say a feed forward neural network. Feed forward neural network, that is nothing but MLP. Now transformer architecture, I'm talking about the transformer. Okay, transformers. These are having two parts. Now, what is the meaning of attention and what is the meaning of feed forward neural network? Okay, so attention. Let me first pick up this attention. What exactly is happening with respect to the attention? We are having this particular, you can say, block that is multi-head self-attention. Just remove this multi-head self-attention, multi-head self. Just focus onto the attention at this moment. We will be going in detail. No need to worry, but focus onto the attention. Like transformers are having the two main part, attention and feed forward neural network. So attention, basically this is used, this is used to retain the context. Retain the context. Retaining the context is nothing but uh, the attention block. This is the duty of attention block. So what is the meaning of attention over here? Let me pay attention to this as well. Okay, so I'm having certain words, uh, like she decided to run around the park to stay fit. Let me try to generate it with Gen AI. Yeah, I don't want to do it by myself. So generate uh, four sentences by using run, which are having different context. Okay. Okay, so this is this you can see over here. Okay, so physical activity. She goes for a run every morning to stay fit. Okay, more or less similar sentence I typed. Okay, operation. The engineer will run the simulation to test the new design. Okay, management. With respect to the management, he helps run the family business with his older brother. And continuous sequence, the movie had a successful run in the theaters for over 3 months. Over here, friends, what we are able to see, the run word is utilized multiple times, but in each sentence the run is having the different meaning. Okay, and that's what is the context, right? So, and this is the task of the attention block to retain this context. Like with respect to which run I'm talking about. Like she goes for a run every morning to stay fit. So over here, I'm talking about the physical activity. Okay, he helps run the family business. So over here, it is management related stuff. Don't focus onto this particular heading, but with the help of these particular sentences, we are able to get that in each and every scenario, this is having the different meaning, and this is the task of attention mechanism or attention block to keep this particular context, to retain the context, so it will be able to predict the next word. If it is not having the context, like kids want to, if it is not having the context to kids, okay, so it will not able to predict, like I'm talking about which run. Are you able to get? Just pay attention to this and ask if you are having any doubt. Just think for a minute and ask if you are having any doubt. All of you, think for a minute and ask if you are having any doubt.
Here we are visualizing. These type of result that we are getting in different contexts. So this is part of transformers that it is providing that in terms of the query.
Yes, basically, Gen AI is not a god, right? Whatever
Mhm.
we have with respect to the pre-training, fine-tuning, whatever we have given, so it is able to provide the outcome with respect to that only. And there
Okay.
must be certain mechanism who is responsible to do these particular things. And that's what like the transformer is there. The transformers are having the further you can say building blocks, attention, then MLP and all. So with the help of these we will be able to predict and provide the outcome uh, uh, with respect to the questions what is being asked,
And
right?
this is due to the neural networks that we are getting multiple results. Like here MLP, we are giving single input and it's giving us multiple contexts. So this is all due to the neural network. It's providing a different multi-layer result.
Feed forward neural network is having the different tasks. Okay, so don't focus onto that, but like getting the different result that is based upon the weights what we will be getting, and how we are going to take like the temperature and all. So if we are restricting with respect to the single input, then we need to set the temperature to 0. Okay, okay, attention and all that will remain same, but if the temperature is set to high, then we will be able to get more outcomes. Huh? So I will tell you that is because of the dimensions. Huh? Transformers architecture is working into the high dimensions. I will come on to that point in today's session only. Then you will be able to get. No need to worry about that. Huh? How
Okay.
getting the different, you can say, answers, huh? Or multiple answers. Huh?
Yeah, okay. Thank you.
Perfect. Huh? Anyone else having any doubt, friends? Okay. So then the next component, feed forward neural network. Okay. Feed forward neural network or MLP, multi-layer perceptron. So over here, it it talks about the facts. The facts. It talks about the facts. Now, it how it talks about the facts. So the data which was utilized in order to pre-train the model. So with respect to that, like the facts are being you can say calculated. So with respect to the facts, uh, it is going to provide the outcome. I will show you like how the facts are driving this particular stuff. But at this moment, what I can say, the feed forward neural network, that is nothing but it talks about the facts, and it is you can say multi-stage or multi-level multi-layer neural networks are being utilized over here, and based upon the like one's output is given to the another layer, then it will working if there are certain on in each and every case, like the true outcome is captured and it is given to the next stage, next neural network, and at the end what we will be getting the true outcome, the correct output basically. Okay, so the main role of feed forward neural network or multi layer perceptron, that is nothing but to provide or to vet the input with respect to the facts and all. Okay, so yesterday we were typing like Narendra Modi is the prime minister and hyphen. So prime minister of India, Maharashtra, such type of answers were coming. So over here, this MLP came into the picture. Okay, MLP, multi-layer perceptron, is providing, it is going to boost the weight with respect to the correct answer what is there inside the pre-trained phase. So that particular knowledge is being utilized, or you can say outside knowledge or outside truth or information is being utilized in order to provide the output. Okay, right? So we can embed third party components over here, we can add external resource information over here in order to get the outcome, and that particular, you can say, answer will be the final one, right? Fine so far?
Yes.
Okay, so these are the two main things inside the transformer architecture. Moving further, like if I'm talking, say she goes for a run, she goes for a run every morning. So this is the sentence. This is the sentence what I'm having. So what exactly is being happening in this particular sentence? The step one, what it will be? Step one, it will be divided into tokens. Into tokens. Then step two, what it will be? Tokens will be converted into token IDs. And step three, what it will be? Each token, just pay attention over here. Each token will be embedded into the vector. This is nothing but the vector database, vector DB. Okay, so these once the tokenization is done, then the tokens are embedded into the vector database, and this is nothing but, you can say, vector. What we know the vectors. What are the vectors? Vectors, 1D array. Vectors are nothing but one dimensional array, right? So try to just focus over here, guys. To this is to all of you. Once the tokens are generated, then these particular tokens are embedded into the vector database. That is the specialized database in order to work with the GenAI. So vector database, vector DB is the mandatory stuff once we are dealing with the GenAI and all. Okay, so these vectors generated these embedded tokens, these tokens are embedded, sorry, into the vector database, and vector is nothing but the one dimensional array. We are having matrix as well. Okay, and that is a two dimensional array. But what about these tokens? What is the dimension of these tokens? Okay, what is the dimension of these tokens? So the dimension of these tokens will be depending upon the models. Okay, so we are having BERT model that is of 768 dimension. Okay, 768 dimension. We are having GPT-4, GPT-4, GPT-4. 4 and 3 both of are having the same dimension, 12288 dimension. Okay, so what is the meaning of this? What is the meaning of this? So over here, just have a look. What is the meaning of this? So once these particular, you can say, tokens are generated, then these are given to the attention mechanism. Okay, and inside the attention mechanism, we will go through with these particular calculations and all in order to provide you the understanding like how things are happening. So dot products, scaling, softmax, don't bother about these particular things. So over here, data 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, so once we are talking about this, these particular, you can say, keywords, you can think in this particular way, like these tokens basically. And what I can say, this is we can represent it with the help of 6 by 6 matrix, like we are having certain keys and the values. Okay, so these are the keys and these are the values. Don't try to like confuse, get confused over here. But inside the attention mechanism, in order to retain the context, say whatever the tokens we are passing. Okay, so these particular tokens, let me try to mention. So say over here, I will, she goes for a run. Okay, she goes for a run. So over here we are having this particular sentence, and you can think particular way. Say this is converted into 2121. Okay, let me mention in this particular way. Okay, she then goes for a run every morning to to stay fit. Okay, and we will be having the tokens. I'm just mentioning certain tokens. Okay, okay, so these are the tokens. I first I was having the sequence of tokens, and then I have done the tokenization. Now I'm having this particular these particular tokens. Now what exactly is being happening, say for each token in the vector db, for each token there will be different weights. Okay, say she is there, and if it is, I'm having say 768 dimension. 768 dimension means this she will be having 768 values with respect to this. Say 2121 is there, and for this we are having say 00 0.001. Okay, and say this is nothing but the zero dimension. On zero dimension we are having this value. On first dimension we will be having 2121, and the value is say 0012. Okay, in this particular way. So I will be having 768 values with respect to the single token. 3 4 and 766 767. Okay, okay, you can take it in this way. So for each token there will be 768 floating points. 768, because I'm talking about the 768 dimension. BERT model is having 768 dimension. So with respect to each and every dimension, I will be having the different floating point. These will be changed. Say 13 over here, probably with respect to this 98 is there, 99 is there. Okay, so So now which floating point? These are nothing but the weights, initial weights, initial weights. Initial weights. These are the initial weights with respect to the dimension. And Swati, probably you will be able to recall. You have asked like how the weighting mechanism is being done. Okay. So with respect to the dimension for each and every token, we will be having the different weights, and the weight will be further fine tuned with respect to the context. It will be further fine tuned with respect to the context and all. The tokens will talk to each other in order to tune itself, and then the the weight is given initially, like the default weight is given to each and every token. Okay. And then they start talking to each other, then they will be having the you can say refined weight, and then the MLP multi-layer perceptron will come into the picture. That is nothing but the outside world knowledge that will be clubbed together, and these particular weights will be varied. Okay. It is like say, uh, you can think in this particular way. So this is say she. For she, this is the token, and say run. In the similar fashion, run is there. Okay. Stay, fit. Okay, you can think in this particular way. The data. So data is there. Data will have certain weights with respect to the visualization, empower user to, right? Are you able to visualize? We will see it practically by using the matrix and all. We will try to uh, proceed mathematically, but try to visualize with the help of this particular diagram. Okay. So each and every, you can say, token will be talking to each other, and then it will be having a particular weight, and that particular weight is assigned to that particular token. Then MLP will come into the picture. That is nothing but multi-layer perceptron. It will talk over here. It will talk with respect. It will try to change the weight. So just have a look over here. After the multi-head self attention capture, the diverse relationship between the input token and the concentrated outputs are passed through the multi-layer perceptron MLP to enhance the model representation capacity. The MLP consists of two linear. We will go through with this mathematically. No need to worry. Uh, so over here, it will try to fine tune the weights with respect to the external, you can say, information or external knowledge. Just think for a minute once again and ask if you are having any doubt. All of you. Shivam, Ayush, Rohit, Raj, Abhishek, Swati, Kunal, Gurmeet, Sachin, Vikas, Viranch, Nilesh, Vijay. Anything, guys, that you are not able to understand?
Actually, this how this conversion have been done to 768 and you assigned the weightage, correct?
No,
So
this is 768 is nothing but the dimension. BERT model is having 768 dimension. If we are talking about the GPT-4, that will be 12288 dimension. So you can think each and every token inside the BERT model will be having the 768 weights. Each and every token inside the GPT-4 model will be having 12288 weights, right?
i- it is for the complete sentence, breaking the complete sentence into the token and then assigning,
Yes,
correct?
yes. For
So
each and every token, Gauge will be having again 768 weights. 4 will be having 768. For each and every token, it will be having. I just uh, uh, you can say mention C only the first token, but it will be applicable to each and every token inside the sentence. So you
Oh,
can think like how huge the data will be. Huh?
okay.
Okay.
And this all the database will consolidate it into a within a single source, or it is going to take the data from each and every one query, like your query, my query, everyone's query, and then put it into a generic database, or will it be a different one?
This is because of the GPUs and transformer over here. Things are happening in parallel. It is not like the sequential operations are being applied or being happening inside the transformer architecture. These things are happening in parallel. Okay,
Okay.
so over here, just have a look. These tokens are given in parallel. Okay, it is not in sequential like data, then visualize, then empower. No, all of these are given in parallel.
Okay.
Okay,
Understood. Thank you.
perfect. Any doubt? Anything that you are not able to get? Okay, so I will uh, set up a context for you to think in that direction. Okay, so what we have seen, the GPT-4 is having 50, all I think almost 50K. The library vocab size is 50K or almost 50K. Exactly, let me try to check it. Vocab size. Size for GPT-4. Almost 50K. GPT-4 took measured bit pair GPT-3. That is 50K, I think. Okay, 5257.
Uh,
So
isn't it
GPT.
something we should basically change with daily inputs of the users, the vocab size?
No. This is fixed. This one is fixed. Like in the GPT-4, we will be having this much of, you can say, words only. Like all from the English language. All the English language words are, you can say, tokenized in such a way it will not be more than 50K. Okay, 5257. Each and everything will come into these particular tokens. You can think in this particular way. Say, I am traveling to say USA. Okay, so over here I'm traveling to USA. Say 1, 2, 3, 4, 5. It can have 5 tokens. Okay, 5 tokens, and then if I'm mentioning travel and ing, so it can have 6 token. Okay, 6 tokens, right? So all the tokens cumulatively create the vocab size. All possible tokens in a particular model are equal to the vocab size. Okay, whatever we are able to type, that will be converted, and all the possible words will be given into the 50K only, 50K tokens. It is not beyond those 50K token, right?
Okay.
Okay, vocabulary. Okay, so let me write it down. All the possible tokens from in a model all the total possible tokens. Tokens in a model are equal to is equal to vocab size. Okay. Okay, so in GPT-3, the vocab size is 50K. Now, you can think in this particular way, calculator. So, 50K, we are having 50K tokens, 5257 into 12288. Okay, so 62 plus, that is not plus, 50 cross 12288. Okay, uh, this is close to 60 billion, 60 million. Mm-hmm. Mm-hmm. 2 millions. Okay, 617 millions. Okay, or what I say if convert to billions. Okay, 617 millions. That is fine now. Okay, so you can think on providing you a base that this say GPT-4 is there with say 8 billion, 8 billion, 8 billion parameters are there, 8 billion parameters. Okay, so in this particular way, we have talked this with respect to the initial phase. Okay, so say we were having the vocab size of this much and the dimension is 12288 because each and every token will be represented into 12288 dimension. So 50257 cross 12288, this is the dimension, so it is giving almost 617 millions word. Okay, millions word, and at this moment probably you will be able to get that how this particular number is coming up, although like this is not the complete calculation. We will proceed further with respect to the attention and MLP layer. Okay, different things will be there, let me try to show. Okay, over here if you are able to see dot product and all. Okay, scaling, softmax these are the different things what are being happening over here. I will go walk you through with the help of these, and definitely you will be able to understand. Okay, it will be in a very, you can say, simple format. So when we will move further, we will be able to get 8 billion words, parameters. Okay, so this calculation is happening because of like we are having this much of dimension, vocab sizes of this much, and then like these particular parameters will keep on, you can say, will be kept on adding, and we will be able, at the end we will be able to get say 8 million or 80 billion or 70 billion parameters. So with respect to the models, I will pick a model and will proceed with all the calculations, and then you will be able to get that yes, this is because of that, like we are able to get this much of parameter, and this is the internal sum. Nobody will talk, like if you are going through with the different sessions onto the internet, nobody will talk about these particular internals, which are being happening, which I'm talking about. Okay, so these things are mandatory to understand the functionality. We will be able to inside the Gen AI from the code perspective, no major stuff is there, because Gen AI is meant to minimize the human effort. So uh, from the coding perspective, less things are there, but from the understanding perspective, a lot of things are there, and that's why like I am going through with these particular calculations, and how we will be able to get this much of parameters in a particular model. We will see it practically, yeah. Okay, so let me walk you through once again. So the calculations, thousands or millions or billions of calculations, and the pre-training on top of that is possible because of the GPU and transformer architecture. GPUs are nothing but the infra, talking about the infra side, and there are like NVIDIA 100, that is the most powerful hardware at this moment which is available and which is utilized in order to pre-train the Gen AI models, and that is the heavy task, and small number of organizations are performing that particular stuff, huh? Moving further, the transformer architecture. So the Gen AI is not possible without the transformer architectures, and over here things are being happening in parallel. Things are, the calculations are being happening in parallel instead of sequential. Okay, and what exactly is there inside the transformer architecture? So there are two main things: attention and feed forward neural network. That is nothing but MLP, multi-layer perceptron. Attention is utilized in order to retain the context, and we know like different words are having the different meaning. Okay, different context. So retaining this particular context is mandatory in order to provide the correct answer. Now whatever we get, okay, whatever we get, that must be vetted from the external, you can say, knowledge or external information. And here comes the multi layer perceptron. It is going to work in a direction to provide the correct outcome. Now moving further, like what exactly is being happening? So if we are passing a sequence of tokens, then it will be divided, the sentence is divided into sequence of tokens. Then tokens are converted into token IDs, and these are given to the vector database. Inside the vector database, the information or the tokens are represented in terms of, you can say, multi dimensions, and the dimension depends upon the model what we are being picking. Okay, say the GPT 3 is having 12288 dimension, and the BERT model is having 768 dimensions. Okay, it means like every token inside the BERT model is having 768 weights. Okay, default weights. Those particular weights will be fine tuned when it is passing from the attention mechanism and the MLP mechanism, MLP layer basically. And inside the GPT-4 we are having 12288 dimensions, and you can think in this particular way, like once a particular word is, you can say, communicating with the another word, and based upon this, like we will be having the modified weights, and then those modified weights are playing a critical role in order to provide the correct outcome. Okay, so over here these tokens are communicating with each other. Tokens communicate with each other. We will understand it more clearly once we will be having the detail, you can say, examples. Okay, I will take one example, and with the help of that example, we will create the matrix, and then proceed with that mathematical calculation and all. Then you will be able to get the understanding, the deeper understanding basically. So each and every token is represented with respect to the weight. Okay, so over here she is the token, and this token is represented into 768 dimension. And with respect to each dimension, what is the meaning? Like, it is having the different weights with respect to the dimension. In each and every dimension, it is having the different weight. And the dimension which is having the and then the tokens and the weights will be picked based upon the interaction, or based upon the inference of each other. One token is going to inference the another token weight. That we will see practically, we will see like how this inference is being happening. But at this moment, what you can capture, so the with respect to the dimensions, we are having the different weights, and these particular weights will be further fine tuned based upon the layer, attention layer, and the feed forward layer, that is MLP. And once we are having these particular, you can say, dimensions and the vocab, then these are playing uh, or these are the base in order to calculate like how many parameters are possible in a particular model. We will see like, okay, we will calculate it, and with respect to say 8 billion parameter, we will be able to get how these things are possible. Okay, moving further, once like we will be having the once the data is passed, then we will be able to get the predictions, and then it will be having the different priorities and all, and we will be able to tune the temperature as well. With respect to the tuning of temperature, we will be able to get the outcome. Setting the temperature towards zero, we will be restricting our outcome. Okay, it will not be the generalized one. And if we are setting it to the higher level, then there are the chances that we will be getting the wrong output. So there is one term that the GenAI is hallucinating itself. That is because of the temperature. Now, if you are not setting the temperature correctly with respect to the domain and all, so GenAI can hallucinate, and it may lead to provide the incorrect output. Okay, I think that's it for this particular session. And in next session, we will be calculating these particular things. Yes, please.
Yeah, just one question. So, and means like let's say there are two examples. One is blue chip funds, correct? And one is
Mm-hmm.
blue chip for children playing. In both
Mm-hmm.
the case, one is basically blue chip fund. We all understand that those are good funds, correct? Where we need to invest. And in the
Mm-hmm.
second case, we are talking about something which is basically used by children for playing.
Mm-hmm.
So, how means is it because of this 50,000 vocabulary and the processing, it is going to basically come up with the correct context?
Yes, so what will happen? So over here, say blue chip fund. Let me take it in this way, blue chip fund. Okay, so blue chip fund, and say blue chip
Let's
what?
say blue chip, maybe we can say blue chip for children's playing, correct? Just taking a random example. Yeah.
Okay, so over here, once this particular, you can say, matrix will be prepared in this particular way. Blue chip, say, for fund for children. Okay, okay. So with respect to this particular blue chip, okay, so we will be having the different weights, and probably say blue chip for children and blue chip for fund.
Yeah.
So over here, it is not like the outcome will not be based upon this particular these particular two tokens. We will be having certain more things like blue chip fund is good to invest, good to invest. Okay. Okay, so good to invest. So these particular tokens will talk to each other. We talk to each other with respect to the weights and all. Okay, and blue chip fund, say, and blue chip for childrens to play. Okay,
Whether it is
so
going to segregate the blue and chip also,
like
or
if
whether it will consider as a single
C
one.
is
Yeah.
capital, then it is not going to segregate probably. Like over here, we are mentioning it as a name.
Ah, okay.
Okay, so depends upon the tokenization mechanism. So what will happen, blue chip fund is okay, so once this particular fund is there, so with respect to the fund, it is going to find out the best, you can say, possible next word, okay,
Mm-hmm.
best possible next word. And how it is possible, because of like the weighting and all that is being done, so blue chip will be having the different, and say with respect to say fund, uh, blue chip, say fund is there, like it is having say 99, you can think the weight is 99.80, 99.22. For
Okay.
children, say blue chip is say 0.88, and then for play, okay, so not play, and invest. So based upon like blue chip fund is good, okay, and say 4 is having 0.4423, okay, 2 is having say 0.9923. Okay, so blue chip is being, you can say, blue chip, and with respect to the fund and all, so the fund and all also will be having like this, say fund children, okay, so we will be having the matrix will be prepared in this particular way, blue chip fund children, okay, and there will be the different weights, once we will create the matrix, you will be able to get the better understanding. Okay, okay, so from this particular you can say matrix, what will be being prepared, like we will be going to have the calculations, a dot products and scaling and softmax, so we will be selecting, we will be having the dot product, say we will be having the inverse of this, and then we will probably do the multiplication of these two matrices. What at that moment, like we will be having the fine-tuned weight, okay, those particular things you will learn, you will see practically.
Okay.
So at the end, what will happen, say blue chip fund, so it will provide the outcome like this, blue chip fund is good to, if like it is fun to invest, and it might be possible, is good to play, good is, fund is a game basically, okay, blue chip fund is for children, okay, it might be going to provide the answer in this particular way, okay,
Okay.
blue chip fund is not good, okay, so you will be getting the fine-tuned weights, and with respect to this, like there will be a best fit, okay, say it will be having say 0.98 probability, it is having say 0.88, or 0.77, whatever,
Mm-hmm.
so it will depends upon ourselves, like how we are going to utilize this. It might be possible what is being predicted over here, that is also not correct.
Mm-hmm.
Okay, so based upon, we will see it mathematically how basically maths is there behind this particular outcome, it is not like things are happening.
Happening randomly.
Okay, so because of the maths, the calculations and all, we will
Mm-hmm.
be able to get the weights, and those particular weights are uh, are playing a critical role in order to predict the next, you can say, word. Okay, once we are having the next word, there will be a probability, and this probability we have discussed like is depending upon the temperature. Okay, hallucination, that is a problem with Gen AI, and that is because of the temperature we are going to set up. Okay, so it is like we will be having the similar words, and similar words can hallucinate the Gen AI. Okay, okay, it can hallucinate the Gen AI. If the context is not clear, then also the Gen AI can hallucinate. If you are not providing the context in clear way, Gen AI has taken in the different way. Okay, so it might be possible like the English grammar is not correct, so it has taken it in the different way, right? So based upon those particular things, each and every token will be having the relationship and relationship with in terms of weights. These particular weights are further fine-tuned with respect to the different mathematical operations, and at the end we will be getting the outcome or the fine-tuned weights, and that particular, you can say, weight is converted into probability. Over here I'm talking about the weight, but at the end what we are having over here, the probabilities. Okay, how these weights are converted into probabilities, that also we will see, right?
Okay.
So no need to worry like how it is going to take the same word into different context. So that is depending upon the attention. So retaining the context. Blue chip is having uh, blue chip over here is having say different meanings, but this is the task of attention mechanism as well, to retain the context, right, and provide you the correct outcome. That's what like the two layers are there, attention mechanism and the MLP. That is going to vet this particular outcome with respect to the external information what we are having. Mhm.
Okay, understood, understood. Just one more small query related to this only. So is it the
Mhm.
same thing which is going to go for our speech recognition also? Because just the thought came when we are saying blue chip as an example, let's say, correct? So it can be a different pronunciation, CHEAP also and CHIP also. So in terms of complete context, it is able to, when we are speaking to Google, correct? And it is writing.
Okay,
The
so there
speech,
are certain fuzzy mechanism is being utilized. Okay,
uh-huh,
fuzzy logics are being utilized. So uh, probably like if you have written a code and if you have basically from the front end side, and
uh-huh.
if like fuzzy is being applied, then it might be possible say hospital. Okay, and if you are typing say host. Okay, so like fuzzy logic is try to, and there is certain fuzzy, you can say, percentage and how much fuzziness you want to have in this particular context. Okay, so based upon like if we are typing this hostiple, so it will convert it into hospital as well. Okay, so fuzziness and all these particular things are being utilized in order to convert it into the correct keyword. So fuzziness, fuzzy logic is the another, you can say, stuff that is being utilized uh, for converting the things into the correct, you can say, word, and depending upon the fuzziness and all, you will be able to get the correct one. The context and all will be compared, and based upon that, like we will be able to get the outcome. Over here as well, like based upon say if speech recognition is there, definitely what we are doing with the speech recognition, we are first converted into the text. Okay, and then text into tokens and all. So it is not like say speech is being proper, you can say, processed as it is. It will be first converted into the encoded, you can say, text, and then it is proceeded for the processing and all, and then different mechanisms are there, those particular things will keep on adding in order to boost the performance of your model. Okay.
Okay. Thank you.
Anything else? Anyone having any doubt? Okay, then we can conclude the session. In the next session, we will be drilling it further, and we will be having the deeper understanding about this transformer stuff. So thanks for joining. Good day.
Thank you so much.